Question 65 says, suppose that an 1,800 kilogram car passes over a bump in a roadway that follows the arc of a circle of radius 20.4 meters. Question A asks, what force does a road exert on the car as the car passes the highest point of the bump if the car travels at 8.94 meters per second? So first we draw a free body diagram. We know that the car is exerting mg on the bump, and in return it's the bump on the ground is pushing up with the same force as normal force, and the mass of the car is 1,800 kilograms. The velocity is 8.94 meters per second. And here I drew a circle so you can easily see the radius of the bump. So the radius is 20.4 meters. So we draw the forces we write out the forces in the y direction. So we have the normal force, which is positive because we're saying that upwards is positive for the y direction, minus mg is equal to mac because it's a centripetal acceleration. So we rewrite that as the normal force minus mg equals the mass times, okay, here we usually put v squared over r, but if theoretically the more velocity we have, wouldn't the car be lighter? So we would make that a negative value, and if we put the normal force onto one side, we would get that the normal force equals the mass times g minus v squared over r. And when we solve for that, we plug in our values and we get about 10,000 newtons. Question B asks, what is the minimum speed the car can have without losing contact with the road as it passes the highest point? So if we think about this question, we know that the car will barely be off the road if the normal force exerted onto the car, or the mg that the car exerts onto the bump, is 0. If the normal force is any less than 0, then that means the car is off the ground. Or not any less than 0, but 0 is where the car would basically be barely touching the ground. And so we would set from the previous question, this equation that we have right here, we would write that again, but we set the normal force equal to 0. As you can see, if you divide both sides by the mass, we would get 0 equals g minus v squared over r. We subtract g from both sides, and we multiply negative onto both sides to get g equals v squared over r. Then we could solve for v. So v is the square root of gr. And we plug in our values, and we get that the velocity of the car when the normal force is 0 is 14.1 meters per second.